Today, our mission is to work with sets. We're going to write sets and identify subsets, and we might even get into talking about complements of a set. So what is a set? Well, it's a well-defined collection of objects, and each of those objects is called an element. A subset of a set consists of all the elements from that given set, so anything that's a member of a set is considered a subset. And you can list your elements as a set within these braces. And again, they're just simply written like this, sort of like a little squiggly type of bracket. Now, there are two ways that we can write sets. The first one is roster form, and that's the way we just list all the elements within these braces. And we did an example of that last week when I asked you to write a list of the first 5 prime numbers. So here I'm asking for a list of the multiples of 3. 3, 6, 9, 12, ... says it goes into infinity. There's no particular end. It's an unlimited set. Now, set builder notation is another way to write sets, and it describes the properties of an element must have in order to be included in that set. Let's take a look at that same set. As we write this in set builder notation, we're going to start with those braces again, and we're going to write and read it this way. The set of all real numbers x such that x is a multiple of 3. So again, it describes the limits or the parameters of what elements could be part of this set. Again, the set of all real numbers x such that x is a multiple of 3. Here's a second example. Let's do one thing at a time. Let's start by finding out that they would like us to write set T, and set T is the set of natural numbers that are less than 6 in both roster form and set builder notation. Well, roster form is the easier of the two, so go ahead and make your list. And again, it's a list of natural numbers that are less than 6. Let's see if we agree. You start off by identifying the name of the set or the notation of the set, which is T. You don't have to write the words roster form. I just did that for example's sake. T is equal to 1, 2, 3, 4, 5. Again, it's a closed set. It doesn't go beyond 5. It doesn't include 6 because it was all natural numbers less than 6. On to set builder notation. We know that the name of the set is T. T is equal to the natural numbers x such that x is less than 6. Again, in words, we just describe the limits and then we put it in its form. Now let's take a look at another example. N is the set of even numbers, even natural numbers that are less than or equal to 12. Once again, take a moment and make your set. Do it in roster form to start. Now let's compare our sets. N equals 2, 4, 6, 8, 10, 12. Again, it includes 12 because it was less than or equal to. Set builder notation. Now again, the name of this set is N, and then we choose a variable since it's not given to us, x such that x is an even natural number, and x is less than or equal to 12. And there you have your set builder notation. Now we can apply this to another form when we're going to write solutions of inequalities as set builder notation. We're going to be given an inequality, asked to solve it, and this one is easy because we have some multiple choice to help us out. Let's start by subtracting 7 on both sides. That leaves me with a negative 5x is less than or equal to 10. Let's divide by negative 5. And I get x is, now before I go too fast, Remember, I divided by a negative, so I reversed the direction of my inequality. And my solution, as I would have written it previously in this chapter, is x is greater than or equal to -2. Now, that's exactly what A looks like, and that's not set builder notation, so A is incorrect. I look at B, and B says x such that x is all real numbers greater than or equal to -2, and that to me looks like a winner. But let's look at the next two choices as well. In the next one, it's written in roster form, and they wanted set builder. And in the last one, it looks like someone forgot to reverse the direction of the inequality. So there's an example of how we can use set builder notation to represent solutions to inequalities. And we'll be doing more of that. Let's try one more of these. Again, take this inequality, solve it, and then let's write the solution in set builder notation. This time, there's no multiple choice. Let's go ahead and subtract 9, leaving me with -4n is greater than 12. Divide by -4, and again, I'm dividing by a negative. I reverse the direction of my inequality, and here is my solution as I would write it if just asked to solve. But they're not asking me just to solve, they're asking me to write my solution in set builder notation. So then I say that n, because n is the variable that is part of this inequality, n such that n is all real numbers less than -3. And that's all there is to set builder notation. It's just a way to write the solution in a descriptive way. So let's talk a little bit about sets and their subsets. You know that set A would be a subset of set B if each of the elements in A is also in B. For example, if set B were equal to -2, -1, 0, 1, 2, and 3, and set A was -1, 0, and 2, well, if every member of A is in set B, which I see they are, then A is a subset. And we use this notation of this, I guess, almost like a U on its side with a line underneath to represent a subset. Now there's something called an empty set or a null set. And that's when a set contains no elements at all. If there's nothing that we have in the set, it's called a null or empty set. There are two ways to represent that. We could be using this braces with nothing inside because it's empty, or we could take a 0 with a line through it. It's one or the other, it's not both. This is not a possibility. Okay, that's putting the two together. It's one or the other. And that's how you write an empty or null set. Well, let's keep talking about subsets. If I give you set A with members or elements 3, 4, and 5, how can I write all of the subsets? They tell us to start with the empty set because an empty set is always a subset of the original set. Then they suggest that we write all the elements that have, all the sets that have only one element. This would be 1. 4 would be another subset. 5 would be still another. Then list the sets that have 2 elements. Well, 3 and 4 would be a subset. They're both in the first set. 4 and 5 are also in that first set, set A, and we would have 3 and 5. Those are all the sets of 2. If I needed sets of 3, I would continue, but that's as far as I go. And then we always include the original set as one of the possible subsets. So then they want to know how many subsets there are of A. There are 8 subsets. I'm going to leave you with this, and we'll continue in our live session today.